Institute of Aeronautical Engineering Autonomous Dundigal. My name is N. Venkat Sai, rule number 23951802226. Subject Power Electronics, subject code AAT-17. Topic Develop a step down chopper based DC drive for coal handling conveyors focusing on speed control and efficiency. Department Electrical and Electronics Engineering. Step down choppers based DC drive for coal handling conveyors, speed control and efficiency. Why focus on coal handling conveyors? Coal conveyors are the backbone of mining operations, and they represent a significant challenge for facility management. These systems consumes up to 40% of total mining facility power, making efficiency optimization critical for operational success. Beyond energy consumptions, precious speed control directly impact throughput rates and equipment longevity. Energy consumption up to 40% of faculty power used by conveyor systems. Operational impact precious speed control improves throughput and reduce mechanical wear. Cost benefits energy savings reduce operational cost and environmental impact. What is a step down chopper? A step down chopper, also known as the buck converter, is an advanced power electronics device that transforms fixed DC input voltage into a lower variable DC output voltage. This semiconductors based solution operates at higher switching frequencies to achieve smooth voltage regulations. This device controls output voltage by modulation the duty cycle, the ratio of on time to the total switching period, enabling precise control over motor speed and torque. Transistor switch high speed semiconductors component that control current flow. Inductors stores energy and smooth current ripple in the circuit. Freewheeling diode produce continuous current path during switch off periods. Output capacitors filters and stabilizes the output voltage waveforms. How does the step down chopper work? The step down chopper operates through a preciously timed switching sequence. When the transistor switch closes, the input voltage is directly applied to the load circuit and current builds up within the indicators, storing energy. When the switch opens, the inductors realize it stores energy through the freewheeling diode, maintaining continuous current flow to the load. This rapid cycling creates an effective average voltage. The mathematical relationship is again average output power voltage is equal to input voltage into duty cycle, where duty cycle range from 0 to 1. Fast switching at kilohertz frequencies enables smooth, efficient voltage regulation without the power losses associated with linear control methods. Applying step down chopper to coal conveyors DC drives. In coal conveyors applications, the step down chopper controllers regulates the armature voltage supplied to the DC motor driving the conveyor's belt. By varying the output voltage, the motor speed is proportionally controlled, allowing precise conveyor's belt velocity adjustment. This enables quick, responsive adjustments to accommodate changing load conditions and operational demands. The real advantage becomes apparent in high efficiency metrics. Step down chopper drives achieve greater than 90% efficiency, substantially outperforming linear control methods that dissipate excess energy as heat. This efficiency gain translates directly to reduced appreciate operational cost and extended equipment lifespan. Voltage control. Chopper precisely regulates armature voltage to DC motor. Speed modulation. Variable voltage enables responsive conveyor speed adjustment. Efficiency gain over 90% of efficiency compared to Traditional linear methods. Closed loop control our enhanced performance. Modern coal conveyors drive systems employ sophisticated closed loop control architecture for optional performance under dynamic conditions. This inner current loop continuously monitors and regulates motor armature current, ensuring precise torque delivery regardless of load variations. Simultaneously, the outer speed loop compare actual conveyor speed against the desired reference speed, calculating the error and adjustment the chopper's duty cycle accordingly. PA proportional integral controllers optimize systems response characteristics, preventing oscillations while maintaining rapid convergence to set point. Advanced systems support four quadrant operations enabling forward and reverse running pulse, regenerating braking capabilities, allowing energy recovery during declaration or downhill transport phase. PI current controller drives motors torque command, current loop, armature current regulation, PI speed controller, adjust duty cycle output, speed loop, reference versus actual speed. Efficiency and energy saving in coal conveyors drives. Step down chopper based drives minimize energy waste by intelligently matching motor voltage precious to operational load requirements. Unlike fixed voltage systems that wastage excess energy as heat, chopper drives only the voltage necessary for the current task. The regenerate braking capability provides additional energy recovery opportunities during conveyors declaration or when transporting coal on downhill selection. The kinetic energy is converted back into electrical energy instead of being loss of mechanical braking. Real world validation comes from the polished brake coal mine remix. While implemented swirl cage motors with chopper drives, the facility achieved superior motors load balancing, optimized slip characteristics, and demonstrated measurable improvements in energy efficiency and operational reliability comparable to previous control methods. Design consideration for coal conveyor DC drives. Creating an effective step-down choppers drive for coal conveyors applications requirement careful engineering designs across multiple subsystems. Selections of the primary power semiconductors, whether insulated gate bipolar translator, metal oxide semiconductor field effect transistors, or silicon control rectifiers, depend critically on voltage and current ratings required by the specific conveyor systems. Inductor sizing must balance current and smoothing needs against physical size constraints, protecting both the motor and supply circuit from excessive current ripple. The freewheeling diode must support continuously current circulation during off periods without voltage drop compressing efficiency. Complete control circuitry for pulse width modulation generate coordinates switching timing while integrated feedback seeing monitoring both motor speed and armature current for closed loop control algorithms. Semiconductor selections choose IGBT, MOSFET or SCR based voltage current requirements. Induction design, size of current smoothing and motor protection. Diode protection, freewheeling path for continuous current during off periods. Control circuitry. BMW generates and comprehensive feedback sensing systems. Visualizing the impact before and after chopper drive implementation. Traditional fixed voltage system. Constant supply voltage regardless of load. Inefficient speed control via mechanical methods. High energy dissipation and heat generation. Excess mechanical stress on motor and conveyor. Limited response to load variations. BMW controlled chopper drive. Adaptive voltage matching load requirements, precise smooth electronic speed regulation, energy savings of to 40% of typical applications, reducing mechanical stress, extend equipment life, rapid stable response to dynamic load changes. Conclusion: transforming coal conveyors operations. Step down choppers based on DC drives represent an transformative technology for modern coal handling operations. This system delivers precious effective speed control essential for maximum throughput while minimize energy consumptions. Closed loop control architecture ensures stable, responsive operation even under dynamic and unpredictable load conditions typical in mining environmental. This combination of energy efficiency improvements and regenerative braking capabilities creates sustainable operational cost, reducing while simultaneously reducing the environmental footprints of mining activities. For mining operation, prioritizing sustainability, reliability, and profitability, invest in advanced chopper drive technology is not merely an operational upgrade. It represents a strategic commitment to competitive advance and long-term sustainability in an increasingly efficient industry. Efficient gains over 90% of efficient with intelligent voltage matching, reliable control, closed loop systems handling dynamic coal mining loads, cost reducing, energy and maintenance saving drive ROI, sustainability, reduced power consumption and environmental impact. Thank you.